All right, time for week slash module 5. Knock on wood, I think this one might be short and sweet, but we will see how much of a rambler I am today. So, the so-called cognitive revolution started to take off after World War II, although the seeds of dissatisfaction with behaviorism was arguably always there. But it was really after World War II and into the 50s and 60s when NASA and computers and all that kind of stuff really started to take off that us over in psychology decided that, maybe we want to talk about cognitive stuff going on inside the mind and the brain, which the behaviorist would not have allowed. Yeah, and we talked about the humanistic psychologists. They were already breaking away from the behaviorists and from the Freudians, actually. And then one school of thought that I don't talk too much about in this class is the Gestalt psychologists over in Europe. There are really a lot of psychologists in Europe who didn't even go along with behaviorism at all. Jean Piaget was not a behaviorist at all. There's a lot of important cognitive psychology research going on in Europe that ends up in all the cognitive psychology textbooks. But in America, and admittedly this is kind of a biased America-centric course, it was mostly all about behaviorism at the time. So probably one of the biggest, most dramatic points in the timeline was this young linguist named Noam Chomsky. He was a real nobody in the academic stage at the time. Nowadays, he's probably one of the most famous academics around. But he was just, I believe, a lowly doctoral student when this happened. You see, sometimes in academia, we write these book reviews. Some book comes out and not everyone has time to read it, but they'd like kind of a lowdown and appraisal of it. So academics, fellow experts in the field, will write little reviews and publish those. And B.F. Skinner, our friend from the last chapter, or last module, had written a book called Verbal Behavior. And in Verbal Behavior, Skinner tried to argue that our language that we use, we talk every day, we invite people to parties, we tell jokes, we do all kinds of strange things with words. Skinner was setting out to explain how our diverse linguistic behavior can be accounted for with behaviorist principles. So stimuli in, behavior out, get feedback from the environment, so on and so forth. Well, Chomsky did a review of Verbal Behavior, and he went to town on it. It was a scathing, brutal review, and it really stirred the pot and got a lot of people thinking. One of the main arguments from Chomsky's review is called the poverty of the stimulus argument. I have a thing here saying be able to put this into your own words for an exam. I don't know if I actually still have this on an exam because I had to restructure this class, but this is really one of the most important arguments or concepts from the whole class, so do pay attention. So the poverty of the stimulus argument goes like this. Individual utterances and sentences that you come up with are so original as a behavior that you've never uttered that sentence before or written that sentence before. So for instance, right now I can say, my telephone is drunk, or I left my shoes in the washing machine this morning. That's not that weird of a sentence. Some people do that. But you see, I can come up with these random sentences that I don't believe I've ever said before. From a behaviorist perspective, how can that be? A behaviorist says you exhibit certain behaviors, and those specific behaviors, or ones that are very similar, let's give them some credit, you emit certain behaviors and those are either punished or reinforced. So if I've never, probably the sentences I'm uttering right now I've never said before, and just reflect on you say new things all day, every day that you've never said before. Those behaviors have never been reinforced. So how could you how could behaviorism account for our linguistic behavior if it can't even account for this most basic fact that we say new things all the time? That is the poverty of the stimulus argument. There's not enough stimuli or behavior for us to have been reinforced or punished on to account for all of our unique behaviors. As far as I'm concerned, this is a pretty devastating blow to behaviorism. When I argue with behaviorists, they'll say, behaviorism. Some behaviorists will say, well, behaviorism actually can account for language. You just have to read up on something called relational frame theory. Or my colleague across the hall, Dr. Bell, says behaviorism's not really meant for accounting for language. It's not good for that. And I really respect that latter one. The former one, I don't know, but the latter one I really respect. It's admitting that your theoretical framework has limitations. It's not a theory of everything. Personally, I think if you are deeply embedded into a theoretical framework and it can't even begin to address something as basic as language, then there's something wrong with your framework. So this is one pretty big blow against behaviorism if you're a radical behaviorist. Of course, it's okay to be theoretically diverse. You can say, hey, when I'm working with kids that are on the spectrum or people with developmental delays, applied behavior analysis, which is based on behaviorism, works really well. So I verse myself in that way of thinking for that purpose. It serves a good purpose, but that's not my end-all be-all outlook on everything. That's perfectly fine. So Chomsky dealt a big blow to behaviorism, depending on who you ask. And his replacement theory was this sort of radical nativism about language. He believed that our brain contains a universal grammar, that your brain is sort of hardwired to eventually learn some kind of language. You have to experience examples of language as you're growing up, and your brain will start to adapt to the specific language that you were born into, but that the circuits necessary to learn the grammar and everything starts off as this universal grammar. It's an interesting theory. I completely disagree with it, but you can see that for Chomsky, he thinks it's ridiculous that your brain just starts with no sort of, just starts with nothing in terms of language, and then just experience itself teaches you everything you need to know about language. He says that's impossible. Poverty of the stimulus argument. There's not enough experiences to teach you every sentence you'd ever need to utter. So there has to be something that exists already in the brain to help you extrapolate from the language that you've experienced before. There was also some research by Curler. He was actually a Gestalt psychologist, so it's not that I'm completely ignoring the Gestaltists. Curler did animal research. There's actually a whole story about him being a spy during this time while he was working with some primates on an island somewhere. He was spying on someone for some government. There were world wars going on right now. I don't know too much about it, but it is an interesting fact. Well, what would happen with Curler is he put primates in these situations where, let's say there's a banana dangling up somewhere high, and the primates can't reach it. They have these boxes and whatnot in their enclosure, but they don't go straight to stacking the boxes. They'll maybe try hopping to see if they can grab the banana. Eventually, you can see it. The apes will occasionally accidentally be pushing these boxes around, and maybe they'll have a box on top of another one, and they'll notice if you can climb on top of both and you have a closer reach to the banana. Eventually you can see it's like night and day. At one point the primate just realizes, aha, I can stack these boxes up, climb on top, and then reach the banana. Now if you're a behaviorist, it's kind of hard to explain that. The primates have never stacked these boxes on top of each other and gone and climbed up and reached the banana. So it's not that behavior can't have been reinforced before. It seems like you have to posit that there's something going on in the primate's brain. It's imagining and guessing and simulating what might happen if I try this. It's trying to problem solve. So there is something going on in the black box. Behaviorists say you can't talk about what's going on in the brain or the mind. But this is a demonstration of, hey, you can't account for everything if you don't allow any type of study or theorizing about what's going on in the brain. And Curler did similar studies where the primates would have to figure out that they can put the sticks together to reach the bananas. So another ding against behaviorism. How can you explain insight learning? An insight is when you just sort of, aha, I just figured it out, and then you go and do it. You exhibit a behavior which embodies the solution to a problem, but you have to have figured it out by thinking about it. And thinking is not something behaviorists were allowed to talk about. You can only talk about stimulus in, behavior out, get feedback from your environment, etc., etc. Now, one reason that it took so long for cognitivism to take off, and one reason why behaviorism was successful, is because, and this is a very nuanced point, it may not be totally clear the first time I go over it. It's because for a long time we really didn't know how could you possibly get from what little we knew about the brain to behavior. It seemed like a bridge too far. We barely knew anything about neurons and cortical structures and neural circuits. We didn't have fMRIs at the time. We didn't have EEGs. We didn't have single cell recording electrodes. So it seemed like there was no way in theory to ever build a bridge between this sort of dumb biological matter, this goop and meat that's inside our head. It's not meat, but it just seemed like you might as well just stick with what you can observe, just stimuli and behavior and consequences acting on that behavior. So one of the things that helped psychologists start to realize, like, hey, we might not be able to directly observe what's going on in that bridge between, stimuli come in, some sort of thinking, perception, decision-making, planning goes on inside the brain, and then some behavior comes out as a result of all that thinking and planning. It can be really difficult to build that bridge, but with the advent of computers, psychologists started to see that, hey, you have this dumb, it's not biological matter, it's, silicon chips, it's vacuum tubes, but you have a bunch of physical substrates that give rise to something like a computer program. A computer program can do the kind of seemingly intelligent things that humans can do. Artificial intelligence programs can do something akin to problem solving or language comprehension. It can generate songs and whatnot. So computer programming was sort of the material they started to build the bridge out of. They'd say a physical substrate like a brain or computer chips can embody a program or a thought. So the theoretical frameworks surrounding computer science were sort of a jumping off point to show it is possible we can build this bridge. And Claude Shannon in 1948, he was a big figure in getting this started. He wrote his dissertation, A Mathematical Theory of Communication. This was a way of precisely quantifying how much information is stored in a bit, how many bits of information are stored in a message. It's kind of hard to explain, but it was a big conceptual leap, this idea of mathematizing information. If you can mathematize information, you say, look at this physical stuff, this is how many bits of information it's storing, this is how many bits of information it can process and transmit, then it's not too far of a stretch to say the brain can do something similar. The brain can store information. The mind can transmit information from one of its subcomponents to another. I just wanted to put this here as a thought. Claude Shannon and this Muppet, I think, bear some similarity to each other. I don't know if this Muppet was inspired by Shannon, but I just wanted to remark on the similarity and just leave you up to your own judgment. One of the most important milestones in cognitive psychology was this symposium that took place in 1956, where you had basically an all-star cast of people from different disciplines. You had Newell and Simon, who were, I guess you could say they were psychologists, but they were also really heavily rooted in computer science, early computer science. You had Noam Chomsky, who was there. He was a linguist. We already talked about him. You had a psychologist, George Miller. He was there. Sometimes to get something really cool started, you just need the right people to come and talk at the right time. And this symposium was a big deal. This is when behaviorism was going strong. And here you get these people getting together saying, I've got these ideas of how we can talk about what's going inside the mind in a way that is rigorous and scientific. So we already talked about Chomsky and his universal grammar. Newell and Simon would program computers to solve problems, but it's one thing to program a computer to solve a problem in sort of an optimal and perfect sort of way. It's another thing to do what Simon and Newell did. They programmed computers to solve problems the way that humans solve problems. So the computer takes a certain amount of time that's similar to the amount of time a human takes. The computers would use strategies similar to how humans would use strategies. It would make the same kinds of mistakes. The computer program embodied a theory of how humans solve problems in general. If you can create a computer program that exhibits the same behaviors, warts and all, of how humans do certain tasks, then you could say that, look, it could be on a computer, on the hardware with the computer chips, or it can be in the brain with the neurons and whatnot. The theory is the program, not the material that the program needs in order to operate. And then you also have George Miller's The Magic Number 7 plus or minus 2. So Miller found that when you get people to memorize a sequence of numbers or letters, people are able to memorize about 7 of them, sometimes as much as 9, sometimes as little as 5. And that sort of represents a information processing capacity. There's something about the brain such that you can store only so many bits of information, but it's not a fixed amount. Some people can store more, some people can store less bits of information in their short-term memory. But what's really interesting is Miller discovered this thing called chunking. So let me see if I can pull up an example real quick of chunking. So if I gave you some letters to memorize, let me make this real big. Yeah, let's make this real big. Nope. I don't know if you can really see that. So I gave you these letters to memorize. I show you one letter at a time. I'm asking you to memorize these. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. So this would be just pushing the limits of what someone can fit in their short-term memory. Only this many bits of information. But humans are able to use their past knowledge, what we now call their semantic memory, to pare down the information processing demands of this task. So let's say if instead of this exact sequence of letters, I instead did the same letters but in a different order, N, B, A, C, I, A, and F, L. So the first sequence was 9 units long. This one is also 9 units long, but anyone can see NBA, that's a widely known acronym. CIA is a widely known acronym. So is NFL. So it's 9 units, but 3 chunks. And Miller, is kind of dealing a blow against behaviorism by saying, Something's going on inside the mind or the brain where people are sort of manipulating the information, making it easier to process, expanding their information processing capacity by strategically using their past knowledge. This is hard to give an explanation for if you're stuck with just stimuli in, behavior out, and response from the environment to your behavior. Another theory that came out around this time was a cognitive dissonance theory. This was in the late 50s, Leon Festinger. The basic idea behind cognitive dissonance theory is that if you have two thoughts that don't cohere with each other, then this creates a level of discomfort. So if you're thinking liars are bad people and I just lied, that makes you feel uncomfortable. It's like if you played these two notes on a piano, it would create this dissonant kind of grating sound. It'd make you kind of uncomfortable. If someone asks you, is animal cruelty wrong? And you say, yes, of course. And then they ask you, well, do you eat beef? You'll start to feel a little uncomfortable with that. So what most people do is what everyone does is somehow or another, you need to get rid of this dissonant feeling, this feeling of discomfort. So with the animal cruelty one, you could quickly come up with an excuse and say, well, I mean, I'm not against eating meat as long as you treat the cows nicely right before you eat them. And, we need to eat beef because, our diet, a human's health is more important than a cow's life. And, you can come up with all these reasons for why these two thoughts aren't dissonant, that they're consistent. And that's what we need, according to cognitive dissonance theories. When we experience that discomfort, we need to create consonance where there is actually dissonance, or we need to create the feeling of consistency where there is a feeling of inconsistency. So one study that Festinger and colleagues did is they brought people into a room and they had them do a very boring task, like they'd pour a bunch of rocks onto a table and ask you to sort them by size or color, just tons and tons of rocks for like an hour, and then come and bring more rocks for you to sort, and then dump out the rocks you already sorted, shuffle them around, and say sort them again. And then after the participants were done, they were paid either $2 or $20. So as they were leaving the building, Festinger and colleagues would plant someone to come in and say, I'm about to go participate in this study. Was it fun? So the participant doesn't know that this person's just an actor who's in on the experiment. And what they recorded was how fun did they say it was, the people who are paid $2 or the people who are paid $20. Well, the people who were paid $2 said that that was really fun, that it was relaxing. They'd come up with reasons for why sorting these rocks for an hour was actually worth their time and pretty fun. The people who were paid $20 says, oh no, that was really boring. I just did it for the money. Now this is kind of strange from a behaviorist perspective because doing this task for $2 means that you are being reinforced for doing the task. Doing the task for $20 means you're being reinforced for doing the task. You're being rewarded for doing the task, but way more. So you'd think that the people who are paid more would have some urge to do it again or feel like that was worthwhile, but you see the opposite when you go and ask people how they felt about doing this task. And according to cognitive dissonance theory, that's because the people who are paid $2 feel like, I just wasted my time. I'm someone who values my time, and I wouldn't do something this boring for just $2. That's creating a sense of cognitive dissonance. So they need to come up with reasons to create consonance where there's dissonance or consistency where there's inconsistency. So they'll make up excuses and say, well, it's not about the money. It was relaxing. I got to focus and I learned a lot about rocks and they felt nice on my fingertips. People will rationalize behavior and with very interesting reasons. The people who are paid $20, though, They were bored out of their minds, just like the people who were paid $2, but they were rewarded handsomely. So there's no inconsistency. I did something boring, but I got paid for it. I got paid pretty well for it. That doesn't feel wrong or inconsistent. That makes sense. People do things that bore them for money all the time. So cognitive dissonance theory took off in social psychology. And so now you have a major theoretical framework that has taken off that is completely at odds with behaviorist theory. And I guess that's another blow against behaviorism. We're in the late 50s and getting into the 60s and 70s. You've got psychologists openly embracing cognitive stuff that's going on inside the mind or the brain. I used to have a few slides here about artificial intelligence and some kind of philosophical arguments about artificial intelligence, but I decided to skip those this time. Well, I still have a little bit. If you're interested, there's a movie called The Imitation Game starring Benedict Cumberbatch and Keira Knightley. It's the real life story of Alan Turing, who helped break the Nazi Enigma cipher the Nazis were using to communicate secret messages and orders and plans over the radio. The British were able to break this code and, strategically deploy their troops in a way to kind of thwart the Nazis. I encourage you to go watch it because Alan Turing was also a big important figure in artificial intelligence, computer science, and if you ever go on a deep dive on cognitive psychology, his name will come up because he was very interested in what makes a mind a mind. Does it have to be something that's on computer? Does it have to be something that's on biological hardware, or could a mind exist on computer hardware? It's some interesting stuff. And it gets to a distinction. I'm not going to get too deep into this stuff. It gets into a distinction between weak AI and strong AI. Weak AI basically says, at best, a computer can only simulate human mental attributes. A computer could never have a mental life the way that a human does. Strong AI says, well, if our brain, which is just a bunch of dumb biological matter, can produce the mental life that we know that we have, why couldn't a computer, in principle, not do the same? There's nothing special about the cells of our brain. Anything that our brain does can be simulated by a computer, so AI can produce a mind just in the same sense that a human has a mind. Most people are weak AI proponents, but you do meet some strong AI components. I know, what's his name? The Tesla guy, Elon Musk, seems to be a strong AI guy, and he's developing technology on the assumption that there's some sort of easily translatable similarity between how brain tissue stores information and between how a computer stores information. I think he's on a fool's errand, but this isn't a philosophy of mind class. But I will say real quick, there is a paradigm in the philosophy of mind called functionalism. This is the idea that the mind is like a piece of software that can be realized on multiple types of hardware. This should seem very familiar because this is exactly well, not exactly, but many cognitive psychologists will at least implicitly assume this. They'll say, we can study the programs, the information storage and information processing stuff that's going on inside the brain, and you don't have to necessarily understand how that stuff emerges from its physical underpinnings. You can study the behavior of the processes themselves and learn how they work. Similar to how you can learn something called object-oriented programming, or even just programming itself. You can learn to code even if you don't know the details of how a computer stores all these bits of information and executes all these code. You could know nothing about the architecture of a computer and still learn how to code. And that's kind of what cognitive psychologists are claiming they're able to do. They're learning about the programs without necessarily having to know about the physical underpinnings of how those programs work. So just to reiterate kind of the key distinction between mainstream American psychology before and after World War II. That's a very rough, blurry timeline. World War II, it's not like behaviorism just dropped dead after World War II. It obviously stuck around and is still around. But for behaviorism, you can observe stimuli that you expose to the organism. You can observe behavior. You can measure that, quantify that. But everything that goes on in between is like a black box. Behaviorists were very emphatic. You can't observe the stuff going on in this box, so let's keep it out of our theories. We're trying to stay above board and be truly scientific. This is actually an oversimplification because, according to Skinner, the important thing is not stimulus in, behavior out. The important thing is behavior out, and then the environment, in turn, influences whether you emit those behaviors again or not. But it's a good rough schematic. For cognitivism, they still use objective observable stimuli and behavior, but their theories are encouraging. They say, box is open, come on in. You can speculate about what's going on inside people's mind. You have to design clever experiments that will show you what's going on inside the mind, give you some kind of basis about how people are making the decisions they're making, or how do people decide what they're seeing or what they're not seeing, how do they perceive. You have to have the right experimental data, and nowadays you can even use neuroimaging to get even more hints about what's going on inside the box. But cognitivism fundamentally wants to know what's going on inside this box to help understand the whole process. So if you open up a cognitive psychology textbook, you're going to see chapters on cognitive neuroscience, because neuroscience is a big part of cognitive psychology now. Sensation and perception, attention. How is it that we're able to attend to certain things, but we will miss certain types of information because we're focusing on one thing and not other things? Memory. How does memory work? What's the best way to study? How are our knowledge and concepts organized? How do we use them? How do we misuse them? Language, Noam Chomsky, that's an ongoing debate. How do people form judgments where we can be biased when we make judgments? How do we make our decisions? How do we reason through a problem? How do we solve problems? These are all the topics that cognitive psychologists study. But in a sense, cognitive psychology as a field of study, as a subfield, studies these specific things. But in another sense, cognitive psychology as a general theoretical framework is something that everyone buys into, or virtually everyone buys into these days. Virtually everyone in clinical psychology or social psychology or developmental psychology, they might not study any of these things in particular, but they assume that we can learn what people are thinking or infer what people are thinking or what people's mental processes are like, and use that knowledge, and they're being scientifically above board when they do so. So there is a distinction between cognitive psychology and its subject matter, as in, like, if you took a class on cognitive psychology specifically, this is the kind of stuff you would learn. But there's another sense in which cognitive psychology or cognitivism is merely the idea that it's okay to talk about what's going on inside the mind. You don't have to just stick to observable stimuli and behavior. You can also speculate about what's going on inside the black box. Here is kind of a canonical architecture of what information processing is like according to cognitive psychology. This is a little dated, but this is how a lot of people organize books on cognitive psychology. They'll start from the beginning of the pipeline and they'll end somewhere at the end of this pipeline. And you can kind of see the influence of computer programming. If you open a computer science textbook, you'll see flow charts like these, showing you how the architecture of a computer or a set of scripts work. But basically, you have stimuli, or the inputs to the system. This is stuff that you see, hear, and smell, and all that. Then you have a very short-term sensory storage area fun fact, you continue to see things for longer than the stimuli are actually there, causing you to see things. So this is technically a type of memory, although I personally don't like to think of it as a type of memory. But then you have the perception and pattern recognition stage, and this can be a blurry line between short-term, very short-term sensory memory storage and actual perceptual processes where you're making sense of your sensory information. And then you have short-term memory where you are drawing on your perceptions of the world, but you're also drawing on your long-term memories, and you are working on information to make decisions and adopt certain strategies and solve problems. You're drawing on the current information and information you have stored long-term in order to form some sort of response or give the ultimate output of the system. So this is kind of the workhorse or workbench of the whole system. And then obviously it wouldn't really work if you can only deal with the perceptions you have right here, right now. You need to store a lot of information for later use. So this is also a major component of the system, is interactions with the long-term memory systems itself and how it interacts with the working memory or short-term memory system. So a couple of applications of cognitive psychology, and we're almost done here. I don't know how short I managed to keep it. So like I said, cognitivism as a general theoretical framework is far more widespread than just the contents of a cognitive psychology book. So in clinical psychology, if you've ever heard of cognitive behavioral therapy, there is a very heavy emphasis on people's thoughts and cognitions needing to be reformatted and reframed. You may have heard of attributional style. Locus of control, grit, and growth mindset are all examples of attributional style. In general, an attribution is the way that you explain phenomena in your environment. So if you walk into a cafe and a bunch of people were giggling and excitedly talking about something, and then they all look over at you after you enter, and then they quickly go quiet and and they kind of frown, some people would say, oh, they were talking about something, but it's not something they want to necessarily share with random people walking up, and they're upset that they can't talk about it anymore. It has nothing to do with me personally. That would be a fairly adaptive, emotionally stabilizing way of attributing what happened to this in the situation to people's motives. A relatively maladaptive and emotionally destabilizing way to attribute the situation would be, oh, these people think that I look like a loser or a dork and they don't like what they see. Our life is full of these situations, and over the long term, the way that we interpret these kinds of stimuli takes a toll on our mental health. Growth mindset has to do with whether you think that your intelligence is something that is fixed and unchangeable, or whether you think intelligence is kind of a work in progress and something you can control. If you have a growth mindset, when you experience failures and setbacks, you tend to interpret that as a lack of preparation, and you say, I do have what it takes, I just didn't apply myself this time. People who don't have a growth mindset will tend to think that setbacks and failures just means that they don't have what it takes, they're a loser, they're dumb. Obviously, this is not a emotionally adaptive way to go about interpreting the world. So all of this stuff I just talked about is laden with cognitive terms. It is helping itself to all kinds of internal mental thoughts and thinking, which is something a behaviorist would not have allowed. In the legal system, there's a lot of cognitive work looking at false memories, false confessions, the accuracy of eyewitness testimony. A lot of laws about cell phone usage while driving comes from applied cognitive research on cell phone distractions. We are way more distracted when we're engaging in a conversation with someone who's not in the car with us compared to when we're just focusing on the road, and people are not aware of how distracted they are. You can manipulate people's memories by asking leading questions. These are all things that cognitive psychologists have studied and have gone on the witness stand and given expert testimony on. And then with design, human factors, user interface design, artificial intelligence, vigilance tasks, some of my colleagues back at Texas Tech would study, they would basically study how well you can detect whether someone's trying to smuggle a knife or something onto a plane, and they'd use basically the same imagery that TSA agents would go through. Yeah, there's tons of applications. If you're interested in cognitive psychology, it's not just the study of these things right here. It's the application of those things to different useful problems in society. So yeah, I'm almost done here, but I will say, yeah, these kind of cover the same thing. I'll just say that with some theoretical frameworks or philosophical views in psychology, there's a sense in which they can become a victim of their own success. So, for instance, pragmatism, or not pragmatism, functionalism, same guy, William James, forgive me. William James's functionalism, not to be confused with the functionalism I talked about a few slides ago, functionalism kind of disappeared. You go back and read about functionalism, and it sounds like a theoretical framework. People called themselves functionalists, but people just stopped calling themselves functionalists after a while and stopped writing about functionalism because arguably, if everyone's a functionalist, then no one's a functionalist. It's just part of the background assumptions of what you're doing. You don't need to defend what you're doing or define what you're doing. Unless you're a philosopher, then that's the whole point. Something kind of like that happened with cognitivism. At this point in psychology and in behavioral sciences, sociology, economics, there's a sense in which we no longer defend the fact that mental processes and thoughts are happening and are an important part of explaining people's behavior. It's just something we all implicitly kind of assume. And I also note at the very end here, and I'm about to stop, is that cognitive psychology has kind of gotten away from the computer metaphor. I've kind of hinted at that. It's more about talking about thoughts and mental processes and trying to link it more firmly back to how the brain does it. People have kind of calmed down on the whole, well, if a computer can do it, then maybe a computer can have a mind. It's some people are still interested in that question, but people nowadays are more interested in linking what they're studying from a cognitive perspective back to how the brain works. And that's it for this module. Hope you enjoyed. Hope I didn't take too long. You have a great day.